Welcome to today's physics lesson. We are going to explore Newton's 3 laws of motion, which describe how objects move and interact. These laws are the foundation of mechanics and help us understand everything from walking to space travel. Get ready to unlock the secrets of motion with Newton's brilliant observations. Let's dive into Newton's first law of motion, inertia. This law states that an object at rest wants to stay at rest, and an object in motion wants to keep moving in a straight line at the same speed, unless a force acts on it. Think about it like this. Imagine you're pushing a shopping cart. If you let go, it will eventually come to a stop because of forces like friction. But if you were out in space and gave that cart a push, it would just keep going. No friction to slow it down. Have you ever been on a bus that suddenly slammed on its brakes? You probably lurched forward, right? That's inertia too. Your body was in motion, traveling at the same speed as the bus, and it wanted to keep moving forward even though the bus stopped. That's why it's so important to wear a seatbelt. The seatbelt provides that external force to stop you from continuing forward and getting hurt. Imagine a soccer ball just sitting on the field. It's not going to move until someone kicks it, right? That's inertia again. The ball is at rest and it wants to stay at rest. It takes a force like a swift kick to overcome its inertia and set it in motion. Newton's first law of motion tells us that objects like to keep doing what they're already doing. Whether it's staying put or moving in a straight line, it takes a force to change that motion. Buckle up, science enthusiasts, because we're about to explore Newton's second law of motion, and it's all about force and acceleration. This law tells us that the acceleration of an object is directly proportional to the force applied to it, and inversely proportional to its mass. In simpler terms, the harder you push something, the faster it goes, and the heavier something is, the harder it is to get it moving. Imagine you have 2 balls, one small and light like a tennis ball, and one big and heavy, like a bowling ball. Now imagine you push both balls with the same amount of force. The tennis ball, being lighter, will accelerate much faster than the heavier bowling ball. That's because the bowling ball has more mass, so it takes more force to get it moving at the same acceleration as the tennis ball. Imagine you're pushing a shopping cart at the grocery store. If the cart is empty, it's pretty easy to push and get moving quickly, right? But what happens when you start filling it up with groceries? It gets heavier, and you have to push harder to make it accelerate at the same rate. That's Newton's second law in action. The more mass the shopping cart has, from all those delicious groceries, the more force you need to apply to get it moving or to change its speed. This law can be represented by a simple equation, F equals ma, where F is the force, m is the mass, and a is the acceleration. This equation tells us that force and acceleration are directly proportional, while mass and acceleration are inversely proportional. Newton's second law of motion helps us understand the relationship between force, mass, and acceleration. The more force you apply to an object, the faster it accelerates, and the heavier an object is, the more force it takes to get it moving. Remember the equation F equals sine ma. Get ready for an exciting ride as we explore Newton's third law of motion, which states that for every action, there is an equal and opposite reaction. This law is all about interactions between objects and how forces always come in pairs. Imagine you're swimming in a pool. When you push off the wall with your feet, you move forward. That's because when you apply a force to the wall, action, the wall applies an equal and opposite force back on you, reaction, propelling you forward. Think about what happens when you jump off a small boat onto a dock. As you push off the boat, action, the boat actually moves slightly backward, reaction. This happens because the force you apply to the boat creates an equal and opposite force that pushes the boat away from the dock. Even something as simple as walking involves Newton's third law. When you walk, you push your foot against the ground, action. In response, the ground pushes back on your foot with an equal and opposite force, reaction, propelling you forward. It's like a constant dance of forces between your foot and the ground. When a rocket launches into space, it expels hot gases downward, action, and the gases in return push the rocket upward, reaction. When you bounce a basketball, you apply a force to the ball, action, and the ball bounces back up with an equal and opposite force, reaction. Newton's third law of motion reminds us that forces always come in pairs. For every action, there's an equal and opposite reaction, and these interactions are what make the world go round. Observe these interactions in your daily life. You'll be amazed at how much physics is happening right before your eyes. And there you have it, science explorers. We've journeyed through the fascinating world of Newton's three laws of motion, and now you're well on your way to becoming physics pros. Let's recap what we've learned. Newton's first law, the law of inertia, tells us that objects like to keep doing what they're already doing, whether it's staying at rest or moving in a straight line. Newton's second law explains the relationship between force, mass, and acceleration. The more force you apply to an object, the faster it accelerates, and the heavier an object is, the more force it takes to get it moving. And finally, Newton's third law reminds us that forces always come in pairs. For every action, there is an equal and opposite reaction. These three laws are the foundation of classical mechanics, and they explain how objects move and interact with each other all around us. Now here's a challenge for you. Try observing Newton's laws in action in your daily life. Keep exploring and remember, science rules. And there you have it, Newton's three laws of motion. They're not just equations and fancy words, they're the keys to understanding how our universe works. From the smallest atom to the largest galaxy, these laws are in control. So next time you see a game of basketball or a rocket launching into space, remember the science behind it all. Keep asking questions, keep exploring, and remember, science rules.